Hey everyone, today we're going to be talking about graphing exponential functions. And today we're going to focus on that decay where the base is less than one and what sort of effect that's going to have on our graph. We're going to do this in the basic way where we're just going to plug in different values for x into our function and see what we get out for y, and that's going to give us our xy coordinate. It's a little more complicated because we got a number out in front here that we're going to multiply, and we've got to deal with this fraction as a base. But using our exponent rules and order of operations, we know how to do it. So let's go ahead and plug -2 in for x and see what we get out for y. And in place of x, I'm going to plug in -2. That's our exponent. Now we know that our exponent rules tell us that if we raise a power to a power, we need to apply that exponent to everything inside the parentheses. So this turns into y equals 2 times 1 to the -2 power, 3 to the -2 power. What's going to happen here, I have negative exponents, so they're going to flip around. The numerator is going to end up in the denominator. The denominator is going to end up in the numerator because of those negative exponents. So I got a lot of steps here, but this is going to turn into 1 to the -2 is going to go down to the denominator squared, and 3 to the -2 is going to go up to the numerator, 3 squared as well. All this, y equals 2 times 3 squared is 9. 1 squared is 1. 9 over 1 is the same thing as 9. So my final answer, 2 times 9, y equals 18. Okay, so with a lot of steps here, but it's going to get easier and easier as we go. So my point is -2, comma, 18. Big process there. Okay, let's do the next one, which is -1. Y equals 2 times 1/3. In place of x, I'm going to plug in -1. And what's going to happen here, instead of just redoing all those same steps, this is going to turn into y equals 2 times 3 over 1. For the same reasons that we did up here, that -1 is going to be applied to the 1, and the -1 is going to be applied to the 3, and everything just gets flipped around. So the denominator becomes the numerator, and the numerator becomes the denominator. And now I'm ready to multiply. 2 times 3 is 6. So my next point is -1, comma, 6. Let's keep going. We are going to do 0. And let's see what happens here. Y equals 2 times 1 over 3 in place of x to the 0 power. Now, anything to the 0 power is 1. So this whole fraction, this whole base, this whole term becomes 1. Y equals 2 times 1. 2 times 1, y equals 2. So my next point is 0, comma, 2. Let's do 2 more. Um, Go on down here. After 0 is 1. So I'm going to do y equals 2 times 1 over 3. 1 to the first power. So anything to the first power is just the base. So this becomes y equals 2 times 1/3. Nothing changes because anything raised to the same one power is the same as the base itself. 2 times 1/3. That's going to give me 2 over 3, right? I just multiplied across. I took the 2, turned it into 2 over 1. 2 times 1 is 2. 1 times 3 is 3. So we are going to deal with some smaller numbers here. And my point is 1 comma 2/3. And we'll deal with that in the next part when we're graphing. Last one. Let's do a 2. Y equals 2 times 1/3 raised to the second power. Here we go again, where we got to apply that 2 to everything inside the parentheses as my first step. GEMDAS. 2 times 1 squared over 3 squared. Y equals 2 times 1 squared is 1. 3 squared is 9. And this, again, let's just multiply across. This becomes y equals 2 over 9. Yes, so my point is 2 comma 2 over 9. Okay, so now let's look at all of our points that we have to plot. We've got negative 218, we've got negative 1, 6. We've got 0 comma 2, 1 comma 2 over 3, and 2 comma 2 over 9. I'm going to plot my x and y axis. And instead of going up by 1, since we need to get up to 18 on my y-axis, I'm going to say every tick is worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And for our x-axis, let's just keep it as one step at a time. So my x-axis is going up by 1s. My y-axis is going up by 2s. So that first point is negative 218, which is negative 2 up to 18. My next point is 1 comma 6, negative 1 comma 6, which is here. My next point is 0 comma 2, which is here. My next point is 1 comma 2/3. It doesn't need to be super exact here. So 1 comma 2/3 is going to be somewhere there. And then my last point, 2 comma 2 over 9, is less than 1/3. So it's going to be somewhere down there. This is an exponential decay. So here's our first example of it going in the opposite direction. Here we're actually starting high and ending low. And that is a characteristic of an exponential function where the base is less than 1. And that's where we're going to end it for today. Thanks, bye.